Hello, my name is Lucas, a master's student at the Federal University of Rio de Janeiro. Today I have the opportunity to quickly show you the research we have been doing in these last years. First is the energy and growth problematic. Global demand for energy is increasingly rising, and we cannot rely only upon fossil fuels. Renewable sources must develop. Solar energy in particular is plentiful and should be harnessed effectively. In this research work, we avail from the quantum phenomena observed at the nanoscale to boost photovoltaics. Here, we utilize metallic nanoparticles made from noble metals such as gold and silver to better convert sunlight into electricity. This is the domain of plasmonics, a new and vast area of physics, with huge applications in many areas. This effect can be briefly described as these collective oscillations from free electrons in the conduction band of this metal, say the electron cloud wobbling around as light comes to interact. These electrons interact with light in such a way they can resonate in specific wavelengths. Furthermore, it can either absorb or scatter light in a controlled fashion. And this control is what is most fascinating here. Size, morphology, and composition are related to the plasmonic responses in these nanostructures. These can be manipulated, which allows the tuning of this plasmonic band to match the solar spectrum rationally and hence maximize light to current conversion. We now have the ability to precisely control the synthesis of several nanostructures. Therefore, a controlled synthesis serves as a powerful tool to achieve higher efficiencies in solar devices. Herein, novel nanostructures are embedded within organic photovoltaics in order to measure this improvement. These are the OPVs, a cheaper and more versatile class of this solar technology. X-ray characterization techniques are extremely relevant for our study, so we can investigate morphology, analyze optical properties, and better design our devices. Thank you for listening, thanks XAYNAN for the opportunity, and I also acknowledge the institutions below.